All of you now, you should mute yourself whenever you will be talking. Only then unmute it. And also you will talk only when I will ask anything. Otherwise, please don't respond and be responsible to mute yourself. Okay. So what happens? And also, uh, I am not switching on my camera because of bandwidth problem. If I switch on my camera, then it may create the bandwidth problem and it may not be audible properly. That's why. The last at the time of interactive session, I will definitely switch on my camera and will interact ourselves. Okay. Okay. So what I was talking, that the feedback in our daily life, just if I start from uh, driving a car. Whenever we drive a car, then always we look at the road in front of our road, and depending on the conditions of the road, we press the accelerator button or, or decelerator button, that is our brake. If the road is empty, that is it is a highway and it is empty road, then definitely the accelerator is pressed and at a certain level or certain speed the car is running. But in front of the road, in front of your car, if some obstacles, some people, some car come in front of you, then definitely will uh, press the brake button and decelerate it. So that means it is one type of feedback, which this feedback is used to control our car. How the feedback is used here? The car, our eye observing the condition of the road, and depending on the conditions, our nerve system work. So whatever our eye is observing, depending on that, our brain is controlling that, what we have to do, and the other nerve system take the decision accordingly. Whether a brake is to be pressed or accelerator is to be pressed, or the a certain constant speed is to be maintained. That is totally decided by our brain, that is our brain, and that is nerve system. Mainly the eye is giving the feedback, what we have to do. Similarly, on the other works also, if you see, depending on your study life, if you see, whenever the exam is knocking to you, then you concentrate more on your study, and also you start to read more and more as much as possible to complete your syllabus or other course pending part of this, and then you revise accordingly and then prepare accordingly, and after exam again you are feel relaxed. So what this based on this our daily life routine, also such things is used to in electronic system to control automatically the output voltage level or any parameter at the output. Okay, so let us see, just let me share my PPT and then let me discuss how this is used in electronic system. Basically, we'll discuss about the feedback in amplifier. Uh, my screen is visible to you?
Yes, sir.
Yes, sir, it is.
Okay, thank you. Okay, so based on so far what I told you, the definition of the feedback is the process of feeding or providing a portion of the output signal. How this output signal is provided, that we'll see. That is a portion of the output signal. It may be a voltage or current back to the input circuit, that is in the input level, is known as feedback. Okay, so just if you think what I told you, based on our observation, that is I, whatever I observe, based on that I is giving the feedback what we have to do, and the other nerve system takes the decision accordingly. That is that depending on the road condition. Similarly, here our I is the output. Okay, so now based on that, similarly, based on the output signal, this a part of this or completely, also it may be a complete voltage output signal may be fed back to the input. Okay, then it is this process is known as feedback. So, and whenever this feedback mechanism is used in amplifier, then it is called feedback amplifier. And that obviously results in dependence on some input and output voltage level, and how this feedback is used to control the output levels, voltage level, how it is effective in controlling such parameters. That is our discussion, and how it will be useful or helpful in a in amplifier system or in electronic system. That will be our discussion. Okay, so before going to that, uh, more details, let me discuss about what feedback and how we are using them. Just if we see here, one basic amplifier as shown here with gain A. Here, suppose do you know amplifier?
Yes, sir.
Yes, sir.
Okay. So if you know the amplifier, then definitely you know the amplifier gain. So amplifier gain, if we say A is the gain, the A is given by V out
Output
here
for
as per this divided by V in, right? So here V out is the output voltage. We are considering a voltage amplifier simply. Amplifier may be a voltage amplifier, maybe current amplifier, maybe transconductance amplifier, resistance amplifier. That we'll see detail later on. Here simply we are considering a voltage amplifier which amplify the input voltage. Okay, and this is what the gain. And here we are considering here basically magnitude. That means here the input output voltage is relation is simply obtained in magnitude, that is it is a scalar quantity itself. Now it may also provide some phase shift. Say for example, if it does not provide any phase shift, then definitely whatever the phase condition here, as you can see here, the same phase will be obtained at the output, and it just the waveform will be same. It will be replicated with amplified version, just like this. Is it clear? Is it clear
Yes,
to
sir.
you?
Yes, sir.
Okay.
Yes.
So if it also provides some phase shift, say here if we consider 180-degree phase shift is there, as for example here, in that case, it will be in addition to the amplification, it will provide some phase shift like this. So this is the original waveform is like this, but it will be amplified with additional phase shift. Okay. Now in this case, what we can see, if we apply the input voltage, the output voltage will be amplified definitely, and then from the output, the amplified output will be connected to the other electronic system, say other control system. Say suppose we want to control a temperature monitoring system, okay, in automated industry, where a temperature monitoring system, that means it will control the output temperature. Output temperature can be controlled by providing say output if you consider AC, air conditioner, that also provide maintain some temperature level, you know. Similarly, if we want to control a fixed particular temperature, then how you can do so by giving some fixed input voltage to that, or controlling the input voltage, you can control the temperature, because there is some devices which depends on the voltage. If you increase the voltage, then its temperature will increase. If you decrease the voltage, then its temperature will decrease, or vice versa. It may be. It depends. If you consider so. Depending on its application, we can use a particular device that will increase or decrease the temperature accordingly. But how will control the temperature at certain level? In this case, if you see here, if you apply certain voltage, it is providing some output voltage as per its gain, but what will be its temperature? Whether it is working properly or not at the output, that information is not known to the input side here. If you say, for example, in our communication system, if I tell you one example, then it will be clear to you. Suppose you have sent one message to your friend from your mobile. That message, whether you have sent, okay, but whether that message is successfully sent to your friend or not, that information you don't have unless otherwise one feedback from the receiving end you have received. Okay, so that information is nowadays is provided by the network system itself. How? You already know that whenever you send the message, one delivery report is received by your mobile, also in your mobile, that the message is successfully delivered. Similarly, in WhatsApp, all of you know that there is different indication. One tick mark, double tick mark, or blue color, green color, that indicates whether the message is successfully sent or delivered, or it is read by the corresponding person. Okay. So this is what you are now at the input side, you are getting the information from the output, that, and accordingly you can able to know the status of the output. So such thing is required similarly in automated system to control the output level. Say for examples, if we want to control the temperature at a fixed level, what we are discussing, that means you have to maintain a constant voltage level here at the output. But now you may ask the question that, yes, if we fix the input voltage, then the output voltage will be constant, and as the gain is constant, the output voltage will remain same. So what is the requirement of such feedback system? Okay, the requirement is this. Suppose you have applied the input voltage, but whether that voltage is successfully applied to the output, again that voltage is controlling the temperature or not. Also, if it is working properly, still you know that depending on some environmental condition, the electronic system characteristics also changes. Say for example, nowadays the semiconductor device, the characteristics of semiconductor device uh, depends on temperature. Do you know this? Already you have studied this.
Yes, sir.
Okay.
Yes.
So for
Yes, sir.
basically, and also you know that for every 10 degree rise in 10 degree centigrade rise in temperature, 10 degree Celsius rise in temperature, the reverse saturation current get doubles for both silicon and germanium semiconductor. So accordingly, we need such devices to control the output level. Okay, so that's why what is done here, a feedback network is connected. Another thing, so that you should remember here, this is the here there is the only input is applied, we are taking the output. There is no connection from the input. So that's here the loop is not closed, whereas it is open. Okay. So that's why it is called open loop amplifier. Such amplifier is known as open loop amplifier. Okay. Now, what we'll do here, as I told you, to control the output voltage level or in an automated system, how we can control that, just try to understand from here. So if we see here, what we are doing, a part of the output voltage or a portion of the total portion of the output voltage or current, it may be connected to the input. As from this diagram, this is what the basic amplifier. Okay. In the basic amplifier now, from the output of this amplifier, a part of this voltage through this feedback network. This is what is known as the feedback network. Okay, and from this feedback through this feedback network, a part of this is connected to the input, and it's basically one adder. Okay, so now this is what our original input signal. Now a part of this is applied, and then according to whether it is increasing or decreasing, based on that, the effective input voltage now is applied here, V in, is to the amplifier. Okay, so how we can control then by using this system? Now look at this here. So if based on this feedback voltage, as a part of this is applied to the input, based on this, whether the output voltage is increasing or decreasing. If suppose the output voltage is increased somehow due to rise in temperature or due to any changes in any parameter. Okay, because in electronic system, it not only a single transistor, it also uses a number of transistors, resistors, capacitors, inductors in a system. Okay, in that case, it may happen sometimes one of the component you need to replace due to aging. A part of the system you may have to replace it. In that case, the completely identical parameters or completely identical components with same characteristics, you cannot replace it or you cannot produce it. Okay, it may be close to that. In that case, the output voltage may increase or decrease. Suppose somehow the output voltage is increased. In that case, look at this. It is proportional to this feedback network has the function to provide a part of the output voltage which is proportional to the output voltage, right? Then if the output voltage is increased, then this feedback voltage VF, that also will increase. So this is V output. Now feedback fraction, suppose the beta is the feedback fraction. What does it? This beta is given by V out divided by V in, or simply the V out divided by this is given by
V out by V feedback.
just a minute. It would be
V feedback by V out
divided by V out. Okay, VF is the feedback voltage and V out is the output voltage. So that means VF is given by beta V out. Okay. So a part of this output voltage now is applied. Now somehow this output voltage is increased, then accordingly this feedback voltage will increase. So if this feedback voltage is increased, now look at this here. It is what if we make this this is applied in opposite to the input signal, in opposite phase with the input signal, then what would be the effective input voltage V in? You tell me. What would be the effective input voltage V in?
Vs minus Vf.
Yes. Vs minus Vf.
V.
Vin is equal to Vs minus Vf. Is it clear?
Yes,
Yes,
sir.
sir.
Yes,
Yes,
sir.
sir.
Yes, sir.
Good. Now, as Vin, now look at this. If Vf is increased, then Vin will decrease. Are you getting
Yes.
this?
Yes, sir.
So, if Vin is
Yes.
effectively decreased, then what would be the output voltage? The output voltage will decrease because output voltage is given by what?
V
V
in.
out is equal to A
V
multiplied
in.
by V in. So, what would be this? So, if now what in again, let me summarize it, better understand. If somehow the output voltage is increased, the feedback network which provides the part of the output voltage which is proportional to as per the feedback fraction, it will provide the feedback voltage Vf. So accordingly, the output, if output voltage is increased, the feedback voltage will increase, which will effectively decrease the input voltage to the basic amplifier, and that will decrease the output voltage. So from this discussion, what you can see that with this mechanism, it has the ability to compensate any change in output voltage, that is increase in output voltage. Similarly, if we see that there is a decrease in output voltage, if the output voltage is decreased, then this Vf also will decrease, and if Vf is decreased, as you can see from here, if Vf is decreased, can you see here? If Vf
Yes,
is
sir.
decreased, then what would be
V
the Vin
Vin
will
V
will
in.
increase or
increase.
decrease?
Out will
Increase.
also increase.
Out will also increase. That means also it has the tendency if it is increased or decreased, so it has the capability to compensate that changes. Okay, that means automatically without changing the input voltage, without doing anything, if you set it some reference voltage, okay, then that any changes that can be controlled automatically through this mechanism. So this is what the feedback which is used to control uh, in, uh, in industry in automated system. Okay, this is a simple form of the feedback amplifier. Now we will see the details. What would be its, how its gain is changed, how, what other parameters it affects. So that also from from the discussion so far we made, you can see that this feedback network, as it is connected from its output to the input, so it has the effect in controlling the input and output voltage. Okay. And also you can see that it forms a closed loop, right? Whenever this feedback network is connected from its output to the input, then it forms a complete a closed loop. That's why the gain with feedback is known as the closed loop. An amplifier with feedback is known as closed loop amplifier, and also the gain by using the feedback in the amplifier is known as the closed loop gain. And the gain of the amplifier, just simply the basic amplifier which is A here, is the open loop gain. Okay, that also you will remember the term, that is the open loop gain and the closed loop gain, or open loop amplifier, closed loop amplifier. Open loop amplifier, that is the basic amplifier which relates the only the input and output without feedback network. But whenever the feedback network is connected, then it completes a path from its input terminal through via its output through feedback network, again back to the input from a closed loop. That's why it's a closed loop amplifier. And the gain with feedback is known as the closed loop gain. Okay. So now let me again go back to the discussion now. So from this, so far we made. Now from this definition, you can understand the feedback in amplifier and what is its effect. Now the types of feedback. So again from the discussion, what I told, primarily the feedback signal, that is a signal feedback from the output to the input, either can input the overall input voltage, I can increase the overall input voltage, or it reduces the overall input voltage. So when, and depending on that, primarily the feedback is of two types. One is the positive feedback, another is the negative feedback. Positive feedback is also known as regenerative feedback, and negative feedback is degenerative feedback. What is this positive feedback? In positive feedback, the feedback signal is applied in same phase with the input signal. So as a result, it effectively increases the input voltage to the basic amplifier. Okay. So whenever it will increase the effective input voltage, then it increases the gain of the amplifier. And when gain of the amplifier is increased, it creates some instability in the system. It also increases the distortion and noise. So in positive feedback, now what we can understood here, the positive feedback is applied, that is for the positive feedback, the feedback voltage is in phase with the input voltage and it increases the overall input voltage. Accordingly, it will increase the output voltage and that will lead to the system instability. So how the system will be unstable, let me again discuss it, just explain this perspective here. Just a minute. Okay, just you see here. Suppose the feedback is positive feedback. So if the feedback is positive, then so far what is our discussion, that for positive feedback, it is applied with the same phase as the input voltage. Here it would be V in equal to Vs plus Vf. For positive feedback, are you getting it?
Yes, sir.
Yes, sir.
So for positive feedback, that means Vs, V in will be increased and it will be added. And for negative feedback,
It will be
what will
minus.
happen?
It will be minus.
In opposite phase. That is, it overall, it will decrease the overall input voltage, Vs minus Vf.
Yes,
So, okay, Vs is the input voltage, what we are applying here. And Vf is the feedback voltage, what we are applying here. Now, it's clear to you? It is Vs.
Yes, sir.
Okay.
In this case, VF is negative.
Yes.
In this case, VF is negative because there is a phase difference of 180 degrees
For
between
negative
VF and
feedback,
VS.
yes. For negative feedback, the applied input voltage, feedback voltage, is in opposite phase with the input signal voltage. This is because, say here, the amplifier may provide the phase shift. As you know, CE amplifier, what is the phase shift between its input and output for CE amplifier?
180 degree.
180 degree phase shift. Good. That means if you apply some input voltage to the CE amplifier, at the output you will have 180 degree phase shift. Now, if your feedback network is simply resistive feedback network, right? As already one of you was telling that to a resistor, whenever a voltage is applied, a part of the output voltage is applied to the input. Similarly, to a resistive feedback network, if that is the voltage divider circuit, which we used here in bias circuit, and in C amplifier, the emitter resistor, that provides some feedback to the input. That we'll discuss. What type of feedback is this? Okay. So whenever the feedback network is simply resistive feedback network, then there will be no phase shift. Okay. If you use a capacitive or inductive or any other transistor, okay, then it will provide another phase shift. Right? As you know, for a capacitor, what is the phase shift? For capacitor inductor,
90 degree.
90 degree. Good. For
Sir, pi by
capacitor,
2.
pi by 2, that is 90 degree. Okay. So that means if you apply a capacitor or inductor and a series of capacitor inductor, it will produce a phase shift depending on the network you have used here. Anyway, so that may provide the phase shift you can control through this feedback network. The amount of voltage also you can control through this feedback network. Now at the input, either this feedback voltage may be in same phase or in opposite phase with the input signal, right? If it is in the same phase, then it will be output voltage will be in same phase and accordingly it will be added. If it is in opposite phase as shown here, this will be just decreasing. It will decrease the effective input voltage. Anyway, how it is? It creates some instability. Let me explain it. Look at this. For positive feedback, the overall input voltage V in, that is V in is applied to the basic amplifier. So feedback voltage increases the input voltage here, V in. Now if somehow the output voltage is increased, then from our previous discussion, the VF will also increase. Yes or no?
Yes, sir.
So
Yes, sir.
if VF is increased, then V in for
Also
positive
increase.
feedback, V in will
Also
also increase. So again, if V in increases, then the output voltage will increase or decrease.
Will
Increase.
increase the
Output voltage will increase. So that
Then, sir,
increase in output voltage also will lead to increase the VF.
V.
Okay. Again, the VF will increase V in. Again, it will increase the output voltage, and this is a cumulative process.
Yes, sir.
So
It will
will
yes,
continuously
sir.
increasing.
It will
yes,
continuously
continuously it
increase.
will increase and increase the output voltage, and it will process in continue indefinitely. So infinite time. So that will leads
and
to
the
increase. Yes, that will leads to increase the voltage at unexpectedly high level. So we will make the system unstable. So that system is not stable at a particular fixed voltage. Are you getting my points?
Yes, sir.
yes, sir.
Okay. So that's why the positive feedback leads to the system instability. Okay, makes the system
The circuit
unstable.
will get damaged after some time. In this case,
Yes, it will when it will
Sir,
stop. Yes,
sir, in negative feedback, V in equals to Vs minus Vf.
in negative feedback, V in equal to Vs minus Vf.
So, but then V in can reach zero at some time.
Uh, okay. That also we'll discuss. It will not be zero because the output voltage will be fixed at some time because your reference input voltage is fixed. Okay. So
Okay, sir.
whenever suppose your voltage changes at certain point, your voltage changes at certain point, right? Either increase or decrease, but your input voltage remains same. So if your input voltage, if you make constant, it remains same, then at certain point it will be fixed or stabilized. It decreases some instability and makes the system stable. Okay, for negative feedback. That's why the negative feedback is used in amplifier system to make the system stable. But for positive feedback, as it makes the system unstable, That's why the positive feedback is not used in amplifier, but it has applications. Where it has the application, it has the positive feedback is used to design oscillator. Now the question is, do you know what is oscillator?
No, sir.
No, sir. Wait.
Yes. So okay. Already you know about rectifier.
Yes, sir.
Yes,
Rectifiers.
sir.
Yes, sir.
What
But
is the
yes,
function of rectifier?
Sir, it converts AC source into DC source. मतलब
yes,
tries
sir.
to convert AC source
And
into DC.
Okay,
There are
Pulsating
many
DC.
good.
types of rectifiers.
Yeah, okay, good. So rectifier is converting. That means a part of the energy, alternating signal energy, is converted to direct signal energy. That means which does not change with respect to time, right? But
yes,
for
sir.
oscillator, it inverse. The effect is inverse. Okay, it provides the alternating signal or generate the alternating signal. Okay, this positive feedback is used to provide to produce the alternating signal which converts the DC signal to AC signal. So how it converts, how it is used to produce the uh, oscillator or to produce the alternating signal, that we will discuss later on. Okay.
Sir, I want to ask a doubt. Can we have
Yes.
feedback amplifiers in previous? Sir, please show the previous slide. Closed
Okay.
loop, open loop. Sir, can we? How this feedback amplifier will work? मतलब how V output will contribute to V input? How will it send the input signal? Means, are you getting my question? How will it V output will send the feedback signal to V input? This is my question because the loop is not closed.
So this
No,
is open
here
loop amplifier.
here it is open loop. That's why here no feedback is used and no feedback is provided.
Okay, sir.
Okay, it is just like this. That's why it is open loop.
VF is
Yes,
only applicable for closed loop amplifier.
closed loop VF is applicable. Look at it. That's why it is open loop.
Okay,
Okay.
sir. I got it.
Okay. So if you understood so far what I told you, then let me come to this derivation part. That is, what would be the relation? What would be the open loop and closed loop gain relationship? Okay. So let us consider this open loop gain is A. Open loop gain means the basic gain of the basic amplifier is A. Now, what would be the overall gain of this amplifier with feedback? That means, if we see here, this is what the within the box, the total within the box, this represents the amplifier with feedback. And then what would be the gain? Gain will be with feedback, the gain will be what? The gain, corresponding gain, AF would be given by V out divided by Vs. So whenever we will consider the feedback in the amplifier. Is it clear to you?
Yes, sir.
Yes, sir.
Yes, sir.
So then what would be this closed loop gain in terms of the basic amplifier gain, that is the open loop gain. Okay. So now from here already we have seen what is, if we consider x0 is the, can you see it properly? Is
Yes,
it
sir.
visible
Yes,
to
sir.
you?
Yes, sir. Yes, sir.
Okay. So A is equal to x0 divided by xi, where xi is the input voltage, x0 is the output voltage. So what is AF? AF is x0 divided by xs. So now AF is equal to, I can write x0 divided by xi. That is, in overall we are dividing both numerator and denominator by xi. And what is xs? If
XI
it is
plus XF.
xi plus xf, good, because already we have seen that
Yes,
xi
sir.
for negative feedback xi equal to xs minus xf. So accordingly Xs is equal to Xi plus Xf. Is it clear? Clear
Yes,
to
sir.
Yes,
all
sir.
of you?
Yes,
Okay,
sir.
good. Now,
Yes, sir.
from this, again, here, Xi plus Xf divided by Xi, and X0 by Xi, what we can write? This is A. As from here, okay?
Yes, sir.
Yes, sir.
And what is this? 1 plus Xf divided by X0, X0 divided by Xi. Can I write in this way?
Yes, sir.
It is Xf by Xi.
X not multiply divide.
Okay. So what is Xf by X0? You tell me. It is what? It is beta.
Beta.
Beta,
Beta.
beta.
Okay. And what is X0 by Xi? It is A.
A.
So what would be AF? Now AF becomes A
A
divided by
divided
1 plus A beta. So this is applicable for which case? For negative feedback. It is for
Negative.
negative feedback. Why for negative feedback? Because we have used here, look at this, Xi plus Xf. That means here
minus
Xi equal to Xs minus Xf. Okay. That's why
yes, sir.
uh, that's why it is Xs equal to Xi plus Xf. For positive feedback, it would be Xi
Xi
equal to
minus Xi.
Xs plus Xf.
Plus Xf.
Okay. And accordingly, this symbol will be negative.
1 minus
So
AB.
yes. So that means A is equal to A divided by 1 plus minus A beta. Here plus symbol is for positive feedback, minus symbol is for negative feedback. And as you can see from here, for negative feedback, the overall gain is increased. As you can see, the denominator is greater than 1. So that means the overall gain is decreased with respect to the open loop gain. A. For For positive feedback, the gain is increased. Okay. So up to this, is it clear to you?
Yes, sir.
Okay.
Yes, sir.
So now, so far, based on this, you note this problem and you will solve it. Next day, we'll discuss. And now, further, if you have any queries, you can ask.
Yes, sir. Sir, one doubt. Sir, here you
Yes.
said that in the negative feedback, the
Hmm.
gain is decreased. So, is it not decreasing the efficiency of the amplifier as the gain is decreased?
Okay, from this paths insight of this negative feedback, and in terms of gain, you can say it is it has the disadvantage. Okay, and it is definitely in terms of that gain, it has the disadvantage that it reduces the gain. Okay, definitely, but by sacrificing the gain, what you can get a stable system. And also it has some other advantage for the negative feedback that we will discuss later on. It reduces noise, it increases bandwidth, it changes the input output impedance as per requirement. That means it has the capability to control the input output impedance to make the system better. Okay. So that's why the negative feedback, just other than this advantage, a disadvantage of reducing the gain, it has several advantages. That's why the negative feedback is used in a amplifier system. Whereas positive feedback, only it increases the gain, but that makes the system unstable. That's why, as it makes the system unstable, so you cannot use it in any electronic system or in any system, right? Suppose you are listening a song, but it continuously at its highest volume, you can't listen it. So you don't have the capability to control its input output. Similarly, if you are watching TV, if you don't have the control to mechanism to adjust its brightness, then it is useless. So that's why the positive feedback is not used in a system, this feedback amplifier system. It is used in oscillators. How it is used, that we'll discuss later on. Okay.
Okay, sir. Thank you, sir.
Any other doubt?
Sir, please share this PPT in group also.
Yes, definitely.
So there is another beta that is current gain IC by IB. So these two betas are related or they are different?
I'm not getting you. Can you repeat?
Sir, in electronics we use another beta for current gain IC by IB. And here
Okay. No. That is totally different. IC by B, that is the current gain for which mode? That is for common
BJT.
in BJT under which configuration?
common emitter.
Common emitter. Yes. In common emitter mode, it is IC. Yes.
Yes,
So
sir.
that is alpha, beta, gamma. That is the current gain for common base, common emitter, and common collector mode. Okay, that is different. So here, though the notation is same, but the definition is different. Okay.
Okay.
Okay, so don't be confused here. Yeah, and don't relate it as it is current gain for common emitter mode. And it is coming from output current to the input current. It may be anything. It may be voltage, maybe current gain like this. So that also we'll see later on when we'll discuss about the different feedback topologies in the next class. Okay. So if you don't have any other queries, then let me stop here. And thank you all for cooperating me to continue the class and conduct the class without creating any noise. And yes, Bolo.
Thank you, sir.
Thank you, sir.
Thank you.
Sir, have you taken attendance?
Thank you, sir.
Thank you, sir.
Sir, attendance need me.
Sir, attendance.
Yes, I'm not getting.
Sir,
Sir,
what is the have you taken the attendance?
Attendance already I can take from here. Okay.
Sir, and please share this presentation in the MS Teams.
Yes, definitely. I'll share it.
Thank you, sir. So can we leave?
Yes, you can leave now.
Thank you.
Okay, sir.
Sir, stop the recording.
Yes, just a minute. Somehow it is.
So can we leave now?
Your screen is freezing, sir. वो सब लीव कर लो चलो तेरा लैपटॉप हैंग हो गया
I have सर वेबसाइट से कर रहा था तो प्रॉब्लम आ रही है माइक्रोसॉफ्ट में.